All right, so 8.4 is the last lesson for this unit. So this is talking about angles of elevation and depression. So pretty much these are word problems using the trig functions. So before we get into actually doing a word problem, which they're so fun, I know you're excited, let's talk about angles of elevation and angles of depression. So they have this diagram right here. And so when you think elevation, I don't know about you, but I think of like a mountain, like how tall the mountain is. So whenever you're doing that angle of elevation, the person or whatever is at the bottom and it is looking up. So it will be the bottom angle right here is what the angle of elevation will be. Okay, that one's pretty straightforward. Angle of depression is a little bit trickier. You have to do an extra step. So when you think depression, you probably think bummed out, feeling down, and it's kind of the same thing with this. You're looking down on the angle of depression. But the angle of depression is a little bit different. So I have this right triangle here. And what do you notice about the angle of depression? Well, there's this dashed line, and it's actually on the outside of the triangle. Okay, so it's on the angle of depression must be on the outside of the triangle. But what's cool about how you can find the angle of depression or whenever you have it, because we need the inside angle right here. We need this part in order to solve for these triangles. So you're going to these two together make a 90-degree angle. So say my angle of depression was 20 degrees. What would that inside angle be? Well, if they equal 90 together, you would do 90 minus 20, which would give you 70. So that would be 70 degrees. All right, say my angle of depression was 30 degrees. Well, you would do 90 minus 30, so that would be 60 inside that right triangle. So when you see angle of depression, start thinking, I'm going to have to do an extra step. That's depressing. That's kind of my little joke for you today. So let's do the first problem. And on all of these, I need you to please draw a picture. You have to. You need to, just to be able to visualize it, what it's asking you. So suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So let's talk about this. We've got a lot of things going on actually. So we have my wind turbine. That's my wind turbine. You're welcome. I know it's beautiful. I've been practicing. And then you also have this person right here. Right? So what are the things that it said about this? Well, it says that person is the eye level is 5.5 feet tall. So this is 5.5 feet. And then we got that down. So from here up to the top, right there, do you see that it makes a right triangle? Okay, so it says the angle of elevation is 56.5 degrees. So where do I put my angle of elevation? Well, I put it right here, because remember, angle of elevation is looking up. So this is 56.5 degrees. And then the other number is, suppose you stand 53 feet from the wind farm turbine. So this bottom distance, you're from the base, 53 feet. Okay. So I think we have all of our numbers labeled, but now we have to figure out what we're looking for. So how tall is the turbine from the ground to its hub? So we're looking for this right here, from here to here. Okay, so we already know from here to here, that's about eye level, is 5.5 feet, right? So we need to keep that in mind. So what we're missing is this part right here, which is the x, right? It's the side opposite of the angle. Weird, do we have a function for that? Okay, so we're trying to find the opposite angle and we have the adjacent angle. So which function are we going to, trig function are we going to use? that would be tangent. So you're going to have the tangent of 56.5 degrees is going to equal, opposite side goes on top, so x over 53. Okay, now we're ready to solve it. So we would multiply both sides by 53. And you would stick that in your calculator. I don't have this one worked out yet. So 53 times tangent of 56.5. I got, let's round it to, did it say? Let's just round it to the nearest whole number. So that would be 80 feet. Okay, 80, it's 80.07, so 80 feet. Okay, so if we know x from here to here is 80 feet, well, we're trying to find the whole distance right here. So we're gonna have to do 80 plus that 5.5 feet. So the distance is 85.5 feet is how tall it is. And that's it. Okay, let's do another one. So you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So this is another eye level one. So you have you. There's you. You're 6 feet tall. Okay, from here to here. All right, you have a cliff. And then you have a little guy here, or girl, rock climbing. I think rock climbing is so crazy. I'm scared of heights though, so I'm a chicken. Okay, so we have that. We have the rock climber, you have you. Now, the problem is from eye level. How far from eye level is the rock climber? So again, it makes a right triangle. And the numbers they give us. So 32 is, so you sight a rock climber on a cliff of 32 degree angle of elevation. So your angle of elevation would be right here. So that's going to be 32 degrees. Okay, and then it says your eye level is 6 feet above. We already wrote that down, so we're good on that. And then you are 1,000 feet from the base of the cliff. So this distance right here is x. And then what is the approximate height of the rock climber from the ground? So rock climber from the ground would be here to here. And we know that from here to here is 6 feet, right? So that's the ground. All right, so obviously this isn't drawn to scale, but it's okay. Oh, why did I put a X right there? I meant to put 1,000. Dang it. So we know, I'm sorry. So why won't this, hold on, I'm having technical difficulties. Sorry, I wrote it wrong. So you are 1,000 feet from the base of the cliff, so that would be 1,000. All right, and what we're trying to find, our X, is the whole distance in yellow from the mountain climber guy to the ground. Okay, so first we need to figure out what this side is right here, right? Let's call that, we'll call it Y. So that'll be Y. That's that side of that right triangle. So Y is opposite of the 32 degree angle, and then 1,000 is adjacent. So again, we're going to be using tangent. So we have the tangent of 32 equals opposite side goes on top. So Y over 1,000. Let's go ahead and multiply both sides by 1,000. Those cancel. You have Y equals, and I'm going to type that on my calculator, 1,000 times the tangent of 32. And it says approximate again. Let's go whole number again. I have 625. So this right here is 625. So now we're ready to find the whole height. So the whole height would be 625 plus 6. So it's approximately 631 feet. Yeah, so obviously that's not drawn to scale, but that's okay. We still used it to get the idea. Okay, next problem. Now we're using angle of depression. So to approach runway 17 of Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent, starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is an airplane at the start of its approach? So this is another tricky one. This is probably like as hard as they get, in my opinion. So I don't know if you know much about sea level. So sea level is at 0. So whenever you are at the ocean, you are at 0 sea level, okay? So whenever you start going inland, the farther inland, usually, not always, but you go up in sea level. So we right now are not at sea level. We're above sea level. I'm not sure how many feet, but we are a certain amount of feet. The only way you can go below sea level or negative feet below sea level would be if you went underwater, of course, or maybe you went really deep in the ground, like in a bunker or something like that. Okay, so we have sea level, and then we have the ground. So I'm going to do the ground right here. And on the ground, we have the airport. There's my airport. Okay, so the airport is 1,000, let's use red. So 1,007 above sea level. And now then we also have an airplane flying around. Are you ready for this? Here's my airplane. Looks pretty good. I'm pretty impressed. Okay, so then it says what else? So we got the 1,007 done. Now the starting height of the airplane is 2,714. So from here to here is 2,714. All right, so to the nearest tenth of a mile, how far from the runway is the airplane at the start of its approach? Oh, we also forgot. They gave us an angle. But remember, this is an angle of descent, so that's depression. Angle of depression, remember? You are bummed out because you have to do an extra step, so it's on the outside of your triangle. Okay, so that's 3 degrees. All right, and then what are we trying to find? It says the distance from the airplane at the start of, how far from the runway is the airplane at the start of its approach? So it looks like we're looking for the hypotenuse on this one, the airplane to the airport. All right, so we have, let's do the tricky part. Let's find this inside angle right here. So we're trying to figure out what this angle is. Do you remember what I said these two add up to be together? Hopefully you're thinking 90. So if these add up to be 90 together, then you would do 90 minus 3, which would give you 87. So that would be an 87-degree angle. Okay, sweet. Now, we know we're trying to find our hypotenuse, so we need to either look for an adjacent side or an opposite side. We can't do an opposite side because they don't tell us anything about the ground. We don't know. Okay, but they do give us enough information to figure out what the adjacent side is. So it's not 2,714, right? So it's 2,714 from sea level, but how much is it from the ground? Because that's all we need to know is from here to here. So you're gonna, to figure that out, you have to do 2,714 minus 1,007. So that would be this side right here would be, what is that? 1,707, okay? So I'm gonna just disregard that number for now. So we know that adjacent side is 1,707. Now we have enough information. We can solve for x. So we're trying to find the hypotenuse, and they give us the adjacent side. So which function are we using? Cosine. So you have the cosine of 87 degrees equals, adjacent side goes on top, 1707 goes on top over x. So now I need to get the x by itself. So first thing we're going to do is multiply both sides by x. That gives me x times the cosine of 87 degrees equals, those cancel, 1707. Then we're going to divide both sides by 87 degrees. I'm going to stick that on my calculator. 1707 divided by cosine of 87. Oops, I'm having problems typing it in. All right, so x equals 32,600, and we'll do a whole number, 616 feet from the airport. Cool. Let's go on to the next problem. So an airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's horizontal distance d from the raft? Okay, so we have another airplane. Oh, this one's not quite as good as the last one. That's okay. Then I have my little life raft. It looks like a weird cloud. Then I have the ocean. Okay, so this one we don't have like the sea level to mess with or the eye level thing to mess with, so we just straight up get to do a right triangle. It's going to be great. But we do have an angle of depression, so there's that. All right, so we have our right triangle. It goes like this. And what do they tell us about this? Well, we have an angle of depression, so that's going to be on the outside of the triangle, so that's going to be 26 degrees. It says the airplane's altitude is 3 kilometers, so that would be right here. That's 3. And then it says what is the airplane's horizontal distance d from the raft, so that would be the bottom. All right, first step, whenever you have an angle of depression, you have to find that inside angle. So we're going to do 90 minus 26 to give us that inside angle, and that will be 64. Okay, so now we're done with that number, so I can cross it off so I don't get confused. So now we're trying to find which side is d to 64 degrees. Well, that's opposite. So we need the opposite side, and then we have the adjacent side. So it looks like we're using tangent. So the tangent of 64 degrees equals, opposite goes on top, so d over 3. All right, let's solve. Multiply both sides by 3. So those cancel. You're left with d equals, does it say what to round? It doesn't. We're going to go to another whole number just because we can, because it doesn't specify. Always make sure you read what it wants you to round to. So this would be, I'll do 1 decimal place. Let's do 6.2 kilometers. Okay. So, yeah, that seems realistic, right? I didn't get like 1,005 kilometers or something crazy, but 6 kilometers is realistic. Okay, so last problem. Homework question says that your angle of depression from the bottom of a house window to a ball on the ground is 20 degrees. Below is your friend's sketch of the situation. Describe your friend's error. So what do you see as the error? Well, they told us the angle of depression. Where does angle of depression go? On the outside. So that should be right there. So that is the issue. All right, that is it for today's notes. Thanks for watching and have a great rest of your day.